All right, welcome back to the notes. So you should have done each of these, try these. So we're going to combine like radicals. And so what I see is that the 2 root 7 and the 3 root 7 are alike, and the 2/3 does not have anything to combine with. So I'm going to leave the 2/3 by itself. And I will group my radicals together. So I have 2 root 7 plus 3 root 7, which I can rewrite. The 2/3 again has nothing to combine with. My like radicals would be 2 root 7 and 3 root 7. So I'll put plus 2 plus 3 root 7. And so this would be 2/3 plus 5 root 7. Whoops, root 7. Okay. Next, I see that I have a square root 6 here and a square root 6 here. Whenever there's no coefficient in front, please put a 1 in front of this one. And then I have some root 5s that can combine here. So I'll do that one off to the side over here. So I have a 5 root 6, and I have a negative 1 root 6 or minus 1 root 6. And then I have a 2 root 5 and a 7 root 5. And then I will group my coefficients, which is 5 minus 1 root 6. And here I'll group my coefficients as well. That's 2 plus 7 root 5s. So this would be 4 square root 6 plus 9 square root 5. And finally, I have a new situation here. So I don't see any other radical 8s. However, I'm going to make a note that square root 8 is not in simplest form. It is not simplified. So before you begin adding or subtracting, you may not have realized it, but I've already evaluated in my head all of these radicals to make sure that they're simplified. I know that square root 7 is fully simplified. I also know that square root 5 and square root 6 are fully simplified. However, square root 8 is not fully simplified because the square root of 8 can be rewritten as 4 times 2, which would be square root 4 times square root 2, which would be 2 radical 2. So I'm going to rewrite that. So I have a 2 plus, that's 2 root 2, plus 8, I just said can be rewritten as 2 root 2. And then I have plus 3 root 2. Now that I have each radical term in fully simplified form, now I'm going to group my like radicals, which would be my root 2's. So this would be 2 plus, I'm going to go ahead and since they're already grouped, I'm going to put all of my coefficients together. So I have a 2, I have another 2, and I have a 3, and then root 2. And so that's 2 plus, that would be 7 root 2. Now on any of these, you could always use a calculator to check to see that you have the correct values. When you add these in your calculator, you should get the same answer as when you add this in your calculator. All right, so back to this example about the crossbars. Recall that when we had a 1 by 1, the length of the crossbar was the square root of 2. And this is from the previous lesson. And similarly, the length of this crossbar when we had a 2 by 2 was the square root of 8. And when we had a 3 by 3, it was the square root of 18. When we had a 1 by 2, it was the square root of 5. A 2 by 4 was the square root of 4 plus 16 is 20. And a 3 by 6 was the square root of 6 is 36 plus 9 would be the square root of 45. Okay, and recall we got those using the Pythagorean theorem. And then it says the length of one leg, and then the wood needed for the legs in feet, and the wood needed for the crossbars in feet. It does say the club advisor also needs to know how much wood to buy for the legs of the kites. Each kite will be 3 foot tall. So the length of the leg will still be 3 feet. And I believe if we look back, there were 4 legs. 1, 2, 3, 4 legs on this kite. And so we would need 4 times 3, which would be 12 feet. And then the wood for the crossbars, just to remind you, there were 8 crossbars. 1, 2, 3, 4, 5, 6, 7, 8 crossbars. And so we would need 8 square root 2s for the crossbars. All right, each kite will be the same height, so this will still be 3, and this will be 4 by 3, which is 12. And then this time we'll have 8 square root of 8. Now, square root of 8 is not fully simplified, so we are going to simplify this. The square root of 8, I'm going to do that off to the side. The square root of 8, again, is the square root of 4 times 2, which is the square root of 4, times the square root of 2, which is 2 root 2. Now, if I need 8 of these, so this is 2 square root 2. If I need 8 of these, I need 2 root 2 plus 2 root 2 plus 2 root 2, and there will be 8 of these. So I will have 8 square roots. I'll have 8 2 square root 2's. So 8 2 square root 2's will be 16, right? I'll add 2 8 times, and I'll get 16 square root 2's. All right, at this point, I want you to pause and try to fill in the rest of your table, and I will catch you back here in the notes.